When we look out into deep space, the sheer scale of the cosmos projects an air of absolute permanence. These galaxies and distant stars appear to sit on a timeline far older than human comprehension. But at a distance of about 200 light-years from Earth sits HD 140283, commonly known as the Methuselah star. Based on the Hubble Space Telescope's fine guidance sensor data, astrophysicists estimate its age at 14.46 billion years. That number becomes a problem when compared to the surrounding cosmos. According to data gathered by the European Space Agency's Planck mission, the universe itself is 13.78 billion years old. This timeline illustrates a strict mathematical contradiction. The Methuselah star appears older than the space containing it. Standard cosmology attempts to resolve this by extending the statistical uncertainty of both measurements. By stretching the error bars wide enough, the very lowest age estimate for the star and the highest estimate for the universe can be made to touch. Yet repeated observations using highly precise instruments continue to return a median age for the star that pushes well past 14 billion years. Different analytical methods, from astroseismology to chemical abundance modeling, consistently output a massive spread of chronological data. A 2 billion-year dating variance for a single object is not a simple rounding error. It points to a flaw in the baseline assumption that the universe operates on an objective, unified clock. In the observer-dependent theory of everything, published by independent researcher Anton Pankratoff, this anomaly is addressed by reevaluating the physical nature of measurement. The theory rests on a specific mathematical axiom. Reality is not a passive object waiting to be catalogued. The observer and the instrument actively constitute the observable state. Under this framework, the age of the Methuselah star is not an intrinsic property burning away inside its core. Age is a configuration, a state generated at the precise moment we apply a mathematical operator to look at it. Whether we use stellar parallax to examine a star, or the cosmic microwave background to map the early universe, each method functions as a unique observation operator. The tool we choose actively shapes the configuration of reality we receive. This aligns with top-down cosmology, a model formulated by physicists Stephen Hawking and Thomas Hertog to describe how the present interacts with the past. In their framework, the universe does not possess an absolute beginning from which linear time flows uniformly forward. Causal structure works retrospectively. Present-day observers select a history compatible with what they are looking at. The Methuselah star and the universe are analyzed through different operators. Measuring the star yields one historical path, the universe another. The incompatible histories refuse to overlap. The contradiction of an object outdating its container does not exist in absolute reality. It exists exactly at the boundary line where two different tools of observation collide. The observer-dependent model discards time as a continuous coordinate of space. Time becomes an iteration index, a simple tally of how many cycles of self-observation have occurred. These two nested loops visualize how the Methuselah star and the broader cosmos are counting these iterations from entirely separate, independent starting states. They do not share a universal zero point. This brings us to a property known as structural incompleteness. Much like Gödel's incompleteness theorems proved that no mathematical system can be entirely self-proving, the same limitation applies to the chronological universe. Achieving perfect coherence across all measurements is mathematically impossible. A fully unified timeline devoid of anomalies cannot be constructed. The 14 billion year age of HD 140283 is the physical manifestation of this limit. When we attempt to close the architecture of cosmic history into a neat package, there will always be an informational remainder left over. No single chronological model possesses the capacity to stitch every piece of observational data into a flawless, self-consistent system. If time and age are simply states generated by the observer, we are left to determine what the official cosmological consensus of 13.8 billion years actually represents. This diagram represents the observer-dependent conclusion. The accepted age of the universe is a configuration stabilized by the sociological coherence of the scientific community. The high degree of agreement surrounding the standard cosmological model gives that specific number a long, stable lifetime. But modern observational data is straining that agreement. The James Webb Space Telescope recently detected highly structured, mature galaxies existing at extreme redshifts, locations in the early universe where they theoretically should not have had time to form. As these anomalies accumulate, alongside phenomena like the Methuselah star, the collective coherence of the observers begins to fracture. When that consensus drops, the 13.8 billion-year configuration literally loses its stability. It ceases to hold a monopoly on cosmological truth. The Methuselah star is a crack in the collective agreement we use to define history. We do not occupy a static, ticking clockwork universe, waiting passively to be measured. We inhabit an interactive, observer-dependent cosmos, where our collective act of looking into the dark builds the history of the light.